Hello, everyone. This is Trista. So I'm glad to be here to give this talk about how to create your distributed and secure database system, leverage your PostgreSQL cluster. So there's something about myself. I'm the Trista, the Sophia's co-founder and the CTO. And in my area, more professional, it's about the distributed database and the database management system, AI management system. So apart from that, I like open source because our project or our community is so active and is so attractive, and I go engage a lot in open source and found it's very valuable, no matter for ourselves or for our product for company. So I engage a lot in Apache Software Foundation. I'm the member of Apache Software Foundation and also the incubator mentor of Apache Software Foundation. Now I guide three incubator projects that Apache AGE, BRPC, and HugeGraph. So I will give some tips or suggestions to your community to help them to create their open source project or their community. Yeah, so that's the basic profile about myself. So today, I will give the tech talk about your distributed database, also my area. And later on, if you have any question and you want to contact me, just give a look on my LinkedIn or GitHub or Twitter. You found myself, found me, and I do my best to answer your question. Yeah, so let's get started with the first part, that's the background, because every new technology it shows up that because people need it. So for our PostgreSQL, I know that people love it. It's so powerful to support millions of the business and scenarios, and people will use the left column status or model that you need the primary nodes and the replica nodes to help you to rebalance your rate queries or to make this cluster become the high availability, right? But the time is coming to the big data era. So this new era raise more requirements for our database. First, volume. Second, velocity. The third one is variety. So how to understand the three keywords. First, volume. Volume, that means because the internet every day creates a lot of data. That means our database needed to help our companies to store or manage the huge data, right? So that means the amount of the data will become the tremendous. The second one is velocity. Because of such huge data, and we need to find or target rows or records, that will become difficult. But for end users, they just want to make their answer become so quicker, right? So that's another issue. The third one is about variety because different scenarios, different user cases will create different data types. For example, the unstructured data or structured data or your like the JSON or XML or files. But for PostgreSQL, one of the feature of this relation database that means it can contain so many database tabs, tabs. For example, the integer or the string or the varchars, or and also include the geometric, right? Your XML or JSON. So today we will focus about the volume requirements and the velocity needs of our big data to create the distributed secure database based on your PostgreSQL database cluster. Yeah. So that means today we will solve two important issues. First, scalability. Because if you can make your cluster become scalable, that means along the time, even though you have more data, it can help you like an auto sharding or resharding, and because of all queries is executed in parallel in different shards. That means you can get your answer or get the readout quicker. Yeah, so also in the big data era, you will have other requirements such as database management or high availability or elastic SQL. But later on, maybe when I have more talks, I will give more suggestions about such issues. But today we'll just focus on scalability and data security. Yeah, so the solution or the great project I want to introduce or we want to use to solve the issue, that is Apache Sharding Sophia. Apache Sharding Sophia, it's the Apache top level project. You don't need to worry about its community or its maturity because this project has been open sourced for more than 5 years. It has an active contribute community. That means so many people do their contributions here, and this project really can provide very valuable features to our end users. So, what is Apache Sharding Sophia? Actually, it's like the great concept of this project is database plus, but its definition, it's an ecosystem to transfer any databases. But currently, we focus on the traditional DBMS like MySQL, PostgreSQL, SQL Server, and Oracle. And later on, we'll involve more databases in this ecosystem. And by leveraging these traditional databases, and it can help upgrade these database clusters to make it become a sharding or distributed system, and also enhance this distributed system with many other wonderful features like the sharding one, yeah, and elastic scaling and distributed transaction, shadow database, and data encryption or SQL audit, etc. Yeah. So it's the Apache 2 license, and on GitHub, if you see its profile, we found it received more than 15,000 stars there and more than 5,000 forks, and also have more than nearly 400 contributors in this community. Yes, that's to their efforts. And also, it has been released for 14.7. So but from my view, I suggest the latest one release because that means it fixes a lot of bugs or have more highlighted features there. Yeah. Okay, so if you want to learn more about this project, just visit his website or Twitter or LinkedIn or join the Slack to talk more about it. But I think that this ecosystem or this project is so open and it's welcoming all of the people, their thoughts, their ideas, or their contribution or thoughts. Yeah. So that's the community about this project. But we also will consider about how does this project can help us and what's the feature of this project. Let's first learn more about its deployment architecture and about its features, because if you want to use it, I firstly suggest that you need to know how to use it, how to deploy it. This ecosystem or this project, actually it provides two products or clients. First, Sharding Sophia JDBC. As its name shows that it's a lightweight JDBC framework. So this product, this client, it implements most of the JDBC interface for your application. If it's developed by Java, that's great to use Sharding Sophia JDBC, and because by this lightweight middleware or by lightweight framework, you can use it. Help you to manage your database cluster, like your PostgreSQL cluster, or MySQL cluster, or Oracle cluster. That means it not just focus on PostgreSQL. It can help users manage more other database clusters. And later on in the future, we want to make sure if JDBC or proxy support the NoSQL database as storage nodes of this distributed system. And it can help you manage the database. It also can help you upgrade your database cluster, become the distributed system. That means the data sharing. Also, like elastic scale out, distributed transaction, rewrite splitting for more traffic, governance, and authentication and data encryption, etc. Anyway, it can help you deal with a lot of requirements for your distributed database system. So that's sharding JDBC. And for our Java application, the second one it's sharding Sophia proxy. And for proxy, if you want to use this project, actually you need to deploy it independently in a new machine. And for application, you can just use this sharding Sophia proxy as an upgraded PostgreSQL database server, right? You can use them like the Navicat, such DB admin tool or CLI to visit sharding Sophia proxy, this distributed PostgreSQL server. And then this sharding Sophia proxy, it can help you to do the data sharding, elastic scale out, and blah, 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 and help you manage your PostgreSQL cluster and MySQL cluster. So you can just pick one of them for your scenarios. And JDBC, that means your application is Java. It's developed by Java. And for proxy, for database DBA, they prefer the sharding Sophia proxy because there's it's nothing to do with your developmental language. Just deploy it, use it, right? Yeah, so that's the product. And next one, we will consider that its feature. Like I said before, even though it has two products or clients for user to pick up, but actually the difference between us is just the deployment way or the model of this product or the style of this product. Actually, they share the same features here. So no matter which product you use, you can use all of the features. And in terms of the features, I want to say that actually you can use all of the features together one time by just figuring all of such requirements or write your configurations. But you can also group or pick up some of the features, group them, become a solution. So today you can see here, there are so many features, right? But today we just use the sharding feature and data encrypt feature to create this, distributed secure database system. And by the way, I want to say, if you want to use sharding proxy currently, it just support MySQL and PostgreSQL database. But for sharding Sophia JDBC, wow, there are more databases it can support. Yeah. So that means by using sharding feature and data encryption feature, you group two features together, right? We don't care about other features. And we pick up the sharding Sophia proxy for the solution. and it will transfer your PostgreSQL instance become a distributed secure database system. And in this distributed solution or distributed database system, you found here it is the computing node. I mean, sharding Sophia proxy. It's the computing node because all of the visits will first reach sharding Sophia proxy. And here it will do a lot of distributed computing. And then it will, because it do some computing, it also needs to do some calculation about your data. So it needs data. That means all of your data or all of your shards will be the storage nodes. And storage nodes, that means your PostgreSQL instance. So here you can see one PostgreSQL instance will be one shard, will be one storage node. So here are three PostgreSQL instance, three shards, and three storage nodes in this distributed database system. And for the computing nodes, here I just give an example. So I draw one proxy, one computing node. Actually, you can deploy extra one or two or more. So you can group these computing nodes as a cluster. That means in this distributed system, you have the computing cluster and storage cluster. And the benefit of this flexible deployment, that means along the time, if you found that computing is not enough or storage is not enough, just deploy more computing and just deploying more storage nodes accordingly. Yeah. Okay, it's flexible deployment system. All right, so after we deploy our computing nodes and storage nodes, second one, we need to put our table or logic structure into this distributed system. So here, I take this T-user table, for example. Imagine you have this distributed system, and now you need to put the user table into this distributed cluster. So how? Here, you need to use the PostgreSQL SQL and distributed SQL. So what's the distributed SQL? Yeah, so let me first give introduction about distributed SQL. So from his, here you can see here, it's a built-in SQL language unique to sharding Sophia that provide incremental functional capabilities beyond the standard SQL. Okay, so simply understanding this definition, that means, for example, if you want to create a table with MySQL database, you cannot use PostgreSQL standard SQL dialect to create a MySQL table, right? So same here, because you upgrade your PostgreSQL instance become a distributed instance, you leverage Apache Sharding Sophia to upgrade it. That means you need to use Sharding Sophia SQL dialect or SQL-like statement to help you this distributed database, like create your sharding algorithm, sharding table, encryption rule, encryption algorithm, and help you know what is happening in this distributed system and get the global metadata of this distributed system. By leveraging distributed SQL, you can know what is happening in this distributed system and help you manage the proxy computing nodes, sharding Sophia proxy computing nodes, and storage nodes, that your PostgreSQL instance. Okay, so you can see some example here. This distributed SQL is similar to your standard MySQL, PostgreSQL, Oracle SQL diet, but it's totally different from them. Yeah, so you can have a feeling or sense about distributed SQL. So let's come back to our last page. By using distributed, because if you just use PostgreSQL, that means you can just create a single standard PostgreSQL table in PostgreSQL instance. But here, if you use distributed SQL, you can create a logic table or sharding table or distributed table named T underline user. For our application, you can just regard the system. In this system, there is the only one logic table, T user. But actually, four sub table or actor table located in different or storage nodes make up this logic table T user, right? So that means here is the logic table. It's mapping to four subtables or actor tables here. Yeah. So by use distributed SQL, you can create this logic table, okay? And that's about the distributed part. The second one, it's about here, the encryption part, because here we not just want to create a distributed system, we also can want or proxy. These computing nodes help us decrypt and encrypt or sensitive data automatically. So how? Here, you need to use distributed SQL to tell your proxy that you want this column telephone number. Wow, it's the data privacy, user privacy, right? You want this telephone number column, it's decrypted and encrypted automatically because all of the queries will first reach out to certain proxy. And when they found that the user want this telephone number is decrypted, and here all of the things will happen. And certain Sophia proxy will will make this telephone number become the cipher text and send the cipher text to the PostgreSQL, that means the story nodes. And so here, this column will contain the cipher text of your telephone number, this plain text from your end user. Yeah, so this mapping or this configuration just by use distributed SQL to tell your sharding Sophia PLC to help you do the data encryption. Yeah, so that's a logical database solution. And the next one, I will give you your workflow to step by step to create this architecture. Yeah. So first you need to have your storage nodes. That means your PostgreSQL instance. Second, create or deploy your sharding Sophia proxy as a computing nodes for this distributed system. A third one, you need to use the DB admin tools to visit sharding Sophia proxy. The next one, that you by using distributed SQL and PostgreSQL SQL to create your logic database and logic table and the sharding rule and encryption rule, blah, blah, blah. And then you can do some tests here. So there's the summary. By step 1, 2, 3, you will create this cluster, and by step 4th, 5th, and 6th, you will create those logic table and databases. And so how to quick start for your sharding Sophia proxy? Just visit this website. And this page will guide you how to quick start for sharding Sophia proxy. Also, you have another option. Just use this Sophia EX boot. Okay, it's a Python tool to help you. One comment to set up your sharding Sophia proxy cluster. Okay. So the next one is about you. Sorry. You visit the sharding Sophia proxy. Here you have found that the sharding Sophia proxy, it's very similar to your standard PostgreSQL CLI, right? And then you use the distributed SQL Two, let the proxy be aware of those PostgreSQL SQL and create this connection between your computing nodes and the storage nodes. So here you use the distributed SQL. Look here, it's similar with your SQL-like statement, but it's different from PostgreSQL standard diet SQL, right? The second one, the next one, you create a sharding rule and encryption rule. You can see sharding account. That means what the sub-actual table you want to create for your logic table, or how many shards you want to create. And then you do some insert table you need to create some insert table. Yeah, insert data for the test. And next one here, you will find that when you do some queries through the sharding Sophia proxy, you will find here that the telephone number, it's the plain text, but that means the sharding Sophia proxy playing this magic. But when you visit your actual PostgreSQL instance, you will find that the text phone number cannot be stored in your PostgreSQL instance. It's become the cipher text for your telephone number. So that's the magic of sharding Sophia proxy help you do. All right, so the next part, that's the complete solution, and the workflow help you to create this distributed secure database solution. That's the main topic of today. But I also append some other features or solutions that can be built from or by Apache Sharding Sophia, like a database gateway, or you just want to do some rewriting, splitting, help the Sharding Sophia, like the Sharding Sophia, help you manage your querying or traffic, or like the database gateway, or you just use it as the data encryption and decryption machine. Yeah. So sharding Sophia, like I said, it has many features, but it's not need for you to use all of the features together. You can just pick some of them or just one of them to create your sharding Sophia solution for your specific user cases. That means this solution is not just the fixed solution. It's flexible. It's open. It's an ecosystem. All right, so any questions, you can just visit my LinkedIn or GitHub or Twitter. I will do my best to answer your question. So that's all for today. Thank you for your listening. Bye.